Hello friends, welcome to our channel. In this lecture, I would like to explain another important example based on the slope deflection method. Already in the previous lectures, I explained the problems based on the fixed supports. Means at the end conditions, it will be fixed supports. And another example based on the simply supported end condition. Another one will be based on the overhanging end condition. But today, I will explain based on the concept which is related to the portal frames, single bay portal frame. So before going to solve any frame, first we would like to confirm whether the frame comes under the sway analysis or non-sway analysis. Non-sway analysis or sway analysis. So the entire procedure of non-sway analysis will be same as the continuous beams, but whenever symmetrical conditions happens, so you can make some note point, means then it will be very easy to solve any type of frames. But you can carry entire procedure by using continuous beams also, you will get that frame. But sway analysis, again there will be two types. One will comes under the pure sway, another will comes under the general sway, which is mostly the type of problems will comes under the moment distribution method. So first, by seeing the frame itself, we will conclude whether that frame comes under the sway analysis or non-sway analysis. So what are the conditions for this sway analysis? So you please note down the conditions for the sway analysis. Then we will discuss whether this comes under the sway or non-sway. So first condition is different end conditions. Different end conditions. And second condition will be unequal heights of the column. Unequal heights of the columns. And third condition will be different moment of inertia for the columns. And final one will be unsymmetrical loading. So by seeing the frame, any one condition happens, then also the frame comes under the sway analysis. So different end condition. What is the meaning here? Different end condition means, so see here, this frame has both end conditions same, like fixed end conditions. For example, for any frame, one end will be fixed, another end will be simply supported. Then that type of frame will comes under the sway analysis. What is the meaning of the different end condition? One end fixed, another end will be simply supported. One end fixed, another end will be free. That type of frames means which is different end conditions. That type of frames will comes under the sway analysis only. Then unequal heights of the columns. Again, you observe here, here there will be 3 meters and here there will be 3 meters. Means for the column height, both AB and CD same, 3 meters and 3 meters. Sometimes there is a chances of asking AB column height will be some 3 meters and BC is the beam, and again CD column height will be some 2 meters. So if you observe clearly, AB column will be 3 meters, CD will be 2 meters, means unequal height of the column. Even though the end conditions are same or different, but there will be unequal heights of the column, means then definitely the type of frames will comes under the sway analysis only. Okay. Then go to the third point, different moment of inertia of the columns. See here, so whatever the end conditions, whether it will be simply supported, fixed or whatever, but the moment of inertia, one side it will be given as I, another side it will be given as 2I, 3I, 4I, means the moment of inertia for the columns will be different here. At that time the frame will comes under the sway analysis only. Means different moment of inertia of the column means if both columns moment of inertia is not equal, property that is I is not equal, then at that situation also the frame will comes under the sway analysis. Unsymmetrical loading. So observe what is the meaning here. Unsymmetrical loading means Here both ends considered fixed or simply supported, one end fixed or one end simply supported, no problem. So already we know the condition, one end fixed, another end simply supported. Based on the different end condition, the column will comes under the sway analysis only. But here both end conditions will be same. But in this 3-meter span, there will be an eccentric load carrying 2 meters at a distance from B and 1 meter from C. So if you see here, there is an eccentric load, means the loading here is not in a symmetric manner. For the same frame, the loading happens exactly at the center, means for the same frame AB and CD, the loading happens exactly at the center, like 1.5 meters, 1.5 meters, means then this type of frames will comes under the non-sway analysis. But here, if you observe here, the loading is based on the eccentric condition. Then at that situation, this type of frames will comes under the sway analysis. Still there will be so many different loading conditions are there. For example, if you see here, whatever the end conditions, there will be an uniform distributed load on the span BC. Both end conditions will be same. Then this type of frames will comes under the column heights also same. Then moment of inertia for the columns also equal. At that time, the problem will comes under the sway analysis. But at this frame, there will be an loading will be acting. For example, this is the 4 meters column, 2 meters by 2 meters distance, a horizontal load is acting on a column. Then this type of frame will comes under the non-sway analysis. Why? Because here an extra horizontal force is acting on a single column. At the same time, if there will be another force acting opposite towards this force, like 2 meters from 2 meters distance, then this type of situations, the problem, so from this side there will be 20 kilonewton load is acting, and this side there will be 20 kilonewton load is acting, means then the type of frames will comes under the non-sway analysis. Why? Because here loading conditions will be same, but only one side will be acting, there is no horizontal force on this column, means then the type of frames will comes under the sway analysis. At the same time, there will be other horizontal force acting with some another distance like 3 meters by 1 meters. Then at that time also the loading is in unsymmetrical manner only. Here 20 and here 30. At that time also the loading is in unsymmetrical manner only. By seeing the any frame, you first confirm whether the frame satisfy any one of the condition, means then definitely that frame will comes under the sway analysis. Okay, then coming to this problem, see here, see here, according to this problem, both end conditions are fixed and equal heights of the column. If there is no moment of inertia, means that is equal to I equal to I. So there is equal moment of inertia of the columns, and at the same time symmetrical loading, uniform distributed load is acting on the entire span. If you cut this span, here 50 and here 50 will be distributed, means symmetrical loading only. Equal moment of inertia, end conditions are same, and equal heights of the column like 3 meters and 3 meters. Out of these four, any one of the column, like for example here 3 and 2 will be happen, means that will comes under the sway analysis. But here all conditions satisfy for the non-sway analysis. And the conditions are same, equal heights of the columns, equal moment of inertia and symmetrical loading. Therefore the frame will comes under the non-sway analysis. Non-sway analysis. So solving of non-sway analysis will be different for different types of problems, but this is same like as the continuous beams. Already you people know the procedure for how to solve the continuous beams based on the slope deflection method. In the same way you can solve this model also, you will get the problem. So always remember what is our first step. Our first step is used to solve the fixed end moments. Fixed end moments. fixed moments. See here, fixed moment means column AB, M bar AB. So if there will be any load, already we people know that if a point load is acting exactly at the center, fixed moments will be minus WL by 8 to plus WL by 8. Like that, we know the forces based on the formulas. Okay, formulas based on the forces whatever they are acting for different loading conditions. But here there will be no load acting on the column AB and CD. If no load is acting means there will be no fixed moments for that particular column. Therefore, I am taking M bar AB, M bar BA and M bar CD and M bar DC will be equal to 0. For example, if there will be any load acting on this particular column means you just calculate that loads also. Okay, like for example, point load acting center means minus WL by 8. Eccentric load acting means minus WAB square by L square and MBA WA square B by L square. UDL is acting means WL square by 12 to plus WL square by 12. Like that you can calculate fixed moments as it is if there will be any horizontal forces acting on a column. If there will be no load means therefore I am taking all the, if there will be no loading conditions given means then definitely take down directly the fixed moments will be equal to 0. Therefore fixed moments for AB and BA column will be equal to 0. Similarly fixed moment for CD and DC column will be equal to 0. Then talking about the fixed moment for CD which is M bar CD. So we already know that the formula for when an UDL is acting on a particular span, the formula will be equal to minus WL square by 12. Substitute the values. W here equal to 16, sorry, 100, and what is the L? Length of this span will be equal to 6 meters and that to square divided by 12. So if please simplify the formula, so you will get directly that one will be equal to minus 300 kilonewton meter. Similarly in the same way M bar DC equal to plus WL square by 12. So same values, that is plus 300 kilonewton meter. So this is the way for finding the fixed moments, same like as the continuous beams only. Okay, then what is the next step? So next step is calculation of the final moments based on the slope deflection equation. So first span AB, talking about the span AB. So I already explained so many times. First one will be MAB, means we are at NDA and seeing B, means talking about MAB span. So and MAB moment. Okay, in the AB span, MAB moment. So what is the formula? So if the far end is fixed condition, then the formula will be MAB plus M bar AB plus 2 EI by L into 2 theta A plus theta B minus 3 delta by L. So if sinking of the support or sway is not given, at that time delta will be considered as 0. Okay. So the formula here, if far end is fixed, so here the intermediate supports always considered as the fixed support only in the continuous beams. But here it is a joint for the beam and the column. So always this intermediate supports considered as a fixed one only. Therefore, M bar AB plus 2 EI by L into 2 theta A plus theta B. So no need to take minus 3 delta by L because of the no sway and no sinking of the supports. And what about M bar AB? M bar AB means there is no load, already we calculated that one will be equal to 0 plus 2E. And what is I value? There is no value is given, therefore I equal to I. By what is length of the span AB here? The length of the span AB will be equal to 3 meters into 2 theta A and theta B. So always remember one note point here. Due to the fixed end conditions, fixed ends, slope remains 0. That is theta A will be, theta D will be equal to 0. So in the formula, whenever you will get theta A and theta D, directly take down 0. For example, if there will be another beam or column acting and that one will be fixed means their slope remains 0. So at the fixed ends slope remains 0. You please remember that one, 0 plus theta b. So if you simplify this one, how much you will get? 2 ei by 3 into theta b. That one will be equal to 2 ei theta b by 3. In the same way, calculate MBA. Means we are at B position and looking A. Means here far end is A and far end is fixed here. If there will be any simply supported end means at that time we need to change the formula. Already I explained while solving the continuous beams. So I will take next frame, far end is simply supported ends. So then it will be easy to know the different end conditions on the frames also. Okay, but here there will be fixed condition, for end fixed means, so you will get same formula, m bar ba plus 2 ei by l into ba, sorry lba into 2 theta b plus theta a. See here m bar ba also equal to 0 plus 2e, here I equal to I and length of that particular column will be equal to 3 meters into 2 theta b plus 0 because of the slope remains 0 at the fixed end. And if you simplify you will get 4 ei theta b by 3. So while after solving, MAB will be equal to 2 ei theta b by 3 and MBA will be equal to 4 ei theta b by 3. Then solve the next step, that is BC, span BC. Okay, member BC. See here, B and C both are intermediate supports only, both end conditions while calculating BC and CB fixed only. Then MBC will be equal to M bar BC plus 2EI by length of BC into 2 theta B plus theta C. See here M bar BC already we calculated, here the obtained value will be minus 300. This one will be the fixed end moment plus 2E wherever I equal to 4I is given in the question, that is 4I by length of the particular span is given as 6 meters into 2 theta b plus theta c. So both the equations will be existed. Okay. So if you simplify, how much you will get here? Minus 300. So 2 one time will be cancelled and 3 times will be cancelled. That one will be plus 4 2 ja 8. 8 ei theta b by 3 plus 4 ei theta c by 3. Theta c by 3. So this equation will be MBC. And you please remember while solving slope deflection method for the portal frames, you always remember due to symmetry of the portal frames, due to symmetry of the portal frames, theta c will be equal to minus theta b. You please remember this end condition, this slope condition, that is theta c will be equal to minus theta b. Wherever theta c will be there, you just substitute minus theta b there. Whenever symmetric condition happens, for non-sway analysis, always you will get this type of condition. And at the same time, slopes, wherever slopes, you take down that one, that end conditions will be equal to 0. Okay, so theta c will be equal to minus theta b and theta a will be equal to theta d. If you not remember this condition means you can solve directly like that also, you will get the problem, but the problem will take lengthy calculations. I will explain both the models, shortcut model due to the symmetrical conditions, otherwise the procedure. Okay, so see here, take down theta c equal to minus theta b and substitute the values, then what you will get here, So what is the obtained value here? Minus 300 plus 8 by 3 ei theta b plus 4 ei, wherever theta b, take theta c, take down minus theta b by 3, and simplify here. 300 plus 1 by 3 8 ei theta b minus 4 ei theta b. Again simplify this one, you will get minus 300 plus 1 by 3 4 ei theta b. So this is the equation for MBC. So after obtaining these three equations, always remember, for the portal frame under non-sway condition, condition, if you obtain MAB, MBA and MBC based on these three equation only, you can simplify the entire formula. In what way it will be means, already while solving continuous beams, we know that at the intermediate supports at the joint, for example, if there will be continuous beams like A, B, C, means some of the moments at joint B like MBA and MBC, MBA plus MBC will be equal to 0. So this is the condition. Sum of the moments at a particular joint will be considered as 0. In the same way, here also at this particular joint position, consider sum of the moments at that particular joint. Means sigma MB will be equal to MBA plus MBC. That one will be equal to 0. So what is the value for MBA here? You please check the final moment. MBA will be equal to 4 ei theta b by 3. Okay, 4 ei theta b by 3. That one will be equal to 4 ei theta b by 3 plus MBC will be equal to, enter this equation, minus 300 plus 4 ei theta b by 3. If you simplify, how much you will get that one? That one will be equal to minus 300 plus 8 ei theta b by 3. Again simplify this one. 8 ei theta b by 3 will be equal to 300. So simplify, finally you will get ei theta b value. That one will be equal to how many times? 900 by 8. One time means 112.5. So 112.5. So after simplifying, the slope at B remains 112.5. Okay. So after obtaining this slope value, what will do means, so wherever ei theta b, substitute ei theta b in the above three simplified equations. Okay. So first here, in the span AB to 112.5, wherever ei theta b 112.5, substitute that one and simplify here. After simplifying, how much you will get? 2 into 112.5 will be equal to plus 75 kilonewton meter. In the same way, here 4 by 3 ei theta b will be equal to 112.5. How much you will get here? After simplifying, MBA will be equal to 75 and that to 4 times. So it will be equal to around 150 kilonewton meter after simplifying. So 2 into 112 75 and again multiply with 2 means, then definitely you will get 150 kilonewton meter directly. So again simplify in the BC equation. How much you will get after simplifying the BC equation? Where is the BC equation? Here it will be there, that is minus 300 plus 1 by 3 into 4 into 112.5. After simplifying this MBC, how much you will get? So MBC will be equal to minus 150 kilonewton meter. Minus 150 kilonewton meter. So therefore, the final moments I am writing here. Final moments. The final moments MAB will be equal to plus 75 kilonewton meter and MBA will be equal to plus 150 kilonewton meter and MBC will be equal to minus 150 kilonewton meter. 150 kilonewton meter. See here, sum of the moments at this particular joint MBA will be equal to MBA plus MBC will be equal to plus 150 and minus 150, that will be equal to 0. Here the condition will be satisfied at the joint. So this is the symmetrical portal frame. Based on these three equation, other three equation can be written by using your own, that is MCB, MCD and MDC. So what are the values you will get here? So here already MBC will be equal to minus 50, means you will get here plus 150 kilonewton meter. Why? Because same 3 meters height and same 50 kilonewton meter will be distributed here, and again here plus 150 kilonewton meter. So here sum of the moments at a particular joint will be equal to 0. So here it will be 150, means here you will take minus 150 kilonewton meter. And again MDC will be equal to plus 75 for MAB, means automatically you will get a negative 75 kilonewton meter. Means based on the logical condition, you can remember directly sum of the moments will be equal to 0. Here you will get MBC for span minus 150, means automatically you will get reverse value 150. Based on that you can take down this is minus 150 and here it will be plus 75, means this one will be minus 75. In case you will get here minus value, means you will get here plus value. Like that, based on the symmetrical condition, you can solve this problem directly by using shortcut. So for this one, what we have to consider, due to the symmetric condition, always remember theta C will be equal to minus theta B. Based on the symmetrical condition, after solving these three equations, sum of the moments at particular joint will be equal to 0. Based on the condition, you can solve these three equations. So first find out the slope of EI theta B and then you can take down the remaining final moments as it is. So this is the one way. Another way means you can solve the formula by using directly without taking this condition. What we have to do means, so see here after calculation of MBC. So see here without taking this value. So up to that point you please remember, and again I will show you second method. Second method. Take down, this is a second method. I will solve the second method also. See here. So without taking that symmetrical condition theta B equal to minus theta C, you take down this equation as 3. Means you will get both the equations like EI theta B, EI theta C. And again solving MCB. Next moment which is MCB, which is for span CB. That one will be equal to, what is the formula? That is M bar CB plus 2EI by L into LCB into 2 theta C plus theta B. Again simplify the above equation. So here fixed moment CB will be equal to plus WL square by 12. That one will be equal to 300 plus 2E, and what is the I value? That value will be equal to 4I. That is 4I. And what is the length of this span? That one will be equal to around 6 meters into 2 theta C plus theta B. If you simplify this one, how much you will get? So you will cancel this one 1 time and 3 time. Means 4 EI by 3, and again multiply with the internal value 300 plus 4 EI, 4 into 2 8, 8 EI theta C by 3 plus 4 into 1, that is 4 EI theta B by 3, and again MCB. So this equation will be the fourth equation. So already in the span AB we obtained two equations. The equations will be, that is first equation. So remove these simplified values and directly take down. First equation will be this one MAB and second equation will be this one. Then already we solved 4 equation, and next solve the another equation, that is MCD and MDC. Then go to the span CD, span CD, span CD. For span CD, again final moment CD will be equal to M bar CD plus 2EI by LCD into 2 theta C plus theta D. Okay, what is M bar CD? Already we know that one will be 0 because of the no loading condition, plus 2E, I value will be constant, and length of that particular span will be 3 into theta C, plus theta D value remains 0 because of the fixed end. Okay. Then after simplifying, how much you will get here? So the finalized value will be equal to 4EI theta C by 3, which is equation number 5. In the same sense, you can calculate the value MDC. So MDC will be in the same way M bar DC plus 2EI by LDC into 2 theta D plus theta C. Again this remains 0, and again this one will be 0 because of the fixed moment. Simplify this one, the length of the span will be 3 meters. Overall you will get 2EI theta C by 3, means this is equation number 6. So there will be total 6 equations. Again same like as the continuous beams, there will be 2 into ABCD. At the time what we are doing, again we can congested these 6 equations into 2 equations. Like at a particular joint we can consider, we can add those 2 equations into 1 equation, and again these 2 equations into 1 equation, and again simplify one over the other. So I will explain that procedure, but this will be lengthy. But in the continuous beams there will be no another option, we have to compulsory simplify that one. But while solving the frames, there is not required this much of procedure. Already I shown in the method 1 in the simple way how can you calculate the entire problem. So after obtaining all these equations, what we have to do means, see here, equilibrium conditions happens at joint B and C. Therefore sigma MB will be equal to 0, and again sigma MC will be equal to 0. For this condition you will get sum of the moments like MBA and MBC will be equal to 0. For this one MCB plus MCD will be equal to 0. MBA plus MBC will be equal to 0. And here MCB plus MCD will be equal to 0. So take down this MBA and MBC equation summation. So where it will be? So see here, MBA equation will be 4EI theta B, which is equation 2, and third equation will be this one. Okay, I am adding those 2 equations. That is equation 2 and 3. Which is MBC. So first solve sigma MB, then after that we will solve this one. Equation 2 plus 3. So already that is a minus MBC. And what about MBA value? That is already we seen here. MBC value will be equal to MBA value will be equal to 4 EI theta B by 3. That is 4 EI theta B by 3. You please simplify this equation. Okay. You please simplify this equation. That one will be considered as 0. After simplifying, what you will get here? Minus 300 plus same LCM. Therefore, you will get 12 EI theta B by 3 plus 4 EI theta C by 3. That one will be equal to 0. Take down this equation as capital A. So already we solved in the equation forms A 1, 2, 3, 4, 5, 6. And again sigma MC will be equal to 0. Sigma MC will be equal to 0 means sum of the moments are the fixed. MCB plus, because of this joint, MCB plus MCD equal to 0. Okay, what is the equation of MCB? MCB will be entire this equation up to here. I am copying that one in the equation 4 and 5. Okay, so take down here the equation 4 plus 5. What about MCD here? MCD equal to 4 EI theta C by 3 plus 4 EI theta C by 3. That one will be equal to 0. If you simplify this one, how much you will get? In the same way, I am writing here, that is equation B. 300 plus 8 EI theta C plus 4 EI theta C. Therefore, 4 EI theta B by 3 as it is I am taking here. And again 8 EI theta C plus 4 EI theta C. Taking 3 common as the LCM, you will get 12 EI theta C by 3. Okay. So there will be two unknowns here, EI theta B and EI theta C. So by using your scientific calculators directly, or again simplify 1 and 2. So in what way we have to simplify this one? So multiplying 1 with 2 and take down common value, like for example, see here, equation, this one will be considered as equation B, and again simplify equation B and C. Simplify equation A and B. So see here, entire this equation, and again entire this equation. So no need to do this calculations manually, you can solve by using your scientific calculators. Otherwise it will take lengthy calculations by using manually. So in what way you have to do this one means, so you can take down into, you will take any common factor value, like both the values 12 12. For example, multiply entire this equation with 3. So what happens at that time? You will get 900. So I am multiplying this equation 300. So this one will be A and this one will be B. 900 plus 12 EI theta B by 3 minus, sorry, plus 36 EI theta C by 3. Then again simplify these two equations. Already 12 EI theta B by 3, 12 EI theta B by 3. You can do subtraction, simplification. So this terms will becomes 0. And here you will get the unknown value of EI theta C. Like that also there will be one procedure you can calculate manually. Otherwise take down these equations directly in your calculators then definitely you will get the two value unknowns like ei theta b value and ei theta c values. So I am giving the procedure how to solve. After obtaining ei theta b and ei theta c, substitute ei theta b and ei theta c in the above equations, like equation taken from starting. Substitute here ei theta b, you will get a value final moment MBA. Here also ei theta b. Here in the equations like 3 4 5, there will be two equations ei theta b and ei theta c. Substitute both the slope values, then you will get MBC final moment. Similarly MCB also you can substitute both the moments. For MCD and MDC you substitute both ei theta c values directly, then you will get all the final moments. So these are the final moments. After substituting the slope values of particular slope like theta b and theta c, you will get all the final moments like MAB, MBA, MBC, MCB, all the values. So already I already explained the final moment values. You will get the same values only you can do in this procedure, that is MAB equal to plus 75 kilonewton meter and MBA will be equal to plus 150 kilonewton. Similarly MBC will be equal to minus 150 kilonewton meter. Similarly MCB will be equal to plus 150 kilonewton meter and MCD will be equal to minus 150 kilonewton meter and MDC will be equal to minus 75 kilonewton meter. So I am writing the values based on the above values because these two equations remains 0 and after summation these two equation will remains 0 because of sigma MB and because of sigma MC, and just I am taking these two values just opposite values. So this is the way for finding the final moments for this type of portal frames. So I think my suggestion is you can go for symmetrical condition, just to solve three moments. Based on that you can write down another three moments in the logical way, then it is very best and very easy to simplify the formulas. After doing all these calculations, maybe while doing manual calculations you will get some errors also, so don't take risk here, you can solve the problem directly. But for continuous beams there is no option, you can solve continuously all these things, but I explained that continuous beams step by step, and I also gave that links in the description, what is the example 1 2 3, all the relevant slope deflection models in this video lecture also, and I will suggest that top right of this corner video. So it is better you can watch the continuous beam example one first and then you can solve this model, then definitely you will get a step by step procedure. Whether you can calculate method 2 which is based on the simplification method, or method 1 which is based on the shortcut symmetrical conditions method. Okay, after obtaining this one, based on these final moments you can draw the bending moment diagrams, okay, and calculate the horizontal reactions and vertical reactions. So based on these final moments I will uh, draw the bending moment diagram. So these are the final moments. I will take the frame as it is ABCD along with the same span conditions. Okay. So this is A, B, C and D. See here there will be MAB which is clockwise movement 75 kilonewton meter will be acting, and MBA will be equal to plus means which is also clockwise movement acting on the span which is 150 kilonewton meter. In the same way for MBC there is another movement like here it will be anti-clockwise movement is acting on the span, I am taking for span, this span, anti-clockwise movement, this one, like this. Means this will be acting on this span which is 150 kilonewton meter. In the same way, for CB, there will be another moment acting like this which is 150. In the same sense, MCD, there will be another movement like which is anti-clockwise movement is acting. I am taking anti-clockwise movement which is 150. In the same sense, for MDC, it one will be minus 75 kilonewton meter. And here minus means anti-clockwise. So like this, anti-clockwise moment will be acting on particular span. So I already explained all the logical conditions in what way have to draw the bending moment. So already I explained so many examples how to draw the bending moment diagrams. So based on these conditions, and again I will explain here also. See here, if there will be a movement which is acting clockwise here. So what I told you means, whenever here, observe here in the image, I will explain in here. So this is A and this is B. So a force will be acting on a column like this. So whenever a force will be acting on a column, what happens? It will slides like this. Okay, means in the same way, what I am telling, a force is acting on a column like this means it will slides like. So I am explaining this bending moment diagram based on the logical way, without hagging and sagging, without towards right and towards left. I am explaining just logically. You observe that whenever a force will comes and act on a column like this, it will slides like this. Means here what happens, whenever a force comes and acts on a column like this column will slide to move like this. So the A will move to up to some distance which is A dash. In the same way, I will take some distance of some unit value of 75 kilonewton meter, which is the force of 1 UT, which is 75. So I am taking with here which is 75 unit force. I am just moving slightly towards right which is 75. And again you can observe here in the upward direction 150 kilonewton load which is acting here like this. Means again in the same way, whenever a force comes and acts like this, then what happens, it will slides like this. Means here in the same way, here column AB will be there, already it will move up to here, this A column moves up to A dash, and again from here a force will be acting on that particular column like here. So again this A tends to move like this, means this B moves to B dash. So whenever a force comes and acts on B means it will move like this, means up to some distance which is 150. 150 value is always higher than 75. So therefore I am taking minimum 75, maximum 70, 150. And after taking these two unit forces, you just add this one. So this is the bending moment diagram for this particular length of the column. So one will be 150. What I am telling means, whenever a force comes and acts like this means it will move up to A dash, and whenever a force will comes and act like this means it will comes and moves up to here like this. In the same way, you please observe here MBC means anti-clockwise movement is acting like this, which is 150. Means there is a span BC like this and there is a force acting on B. Means so here it will be B and a force comes and act like this means it will move upwards. Means this B moves to B dash upwards. Like this there will be a line. Okay. So just I am taking the unit force of 150. With same unit force, how much I will take here. In the same sense, what happens, another force at C will be acting on the same span like CB. Means here it will be acting like this, means So already one will move in upward, and again in the same way the force will comes and act and apply like this external force. It will move again upwards. Means here also it will move. Already the movement will be like this. Means whenever it will force act and comes and act like this means, and again this C moves to C dash, so it will be equal like this. Because here also it will be 150 and here also it will be 150. Means I am telling here, whenever a external force comes and act like this means, this beam will tends to move forward from C to C dash. So this is the logical way. You can remember like this means it will be very easy to draw any type of bending moment. Okay. Otherwise you can depend upon hagging and sagging moments like that. So sometimes it will be very clumsy to draw like that. So after obtaining these two, you can join these two lines. Then again you can see here, so I am removing this one. Just I will take a column to explain. Just I will take any one column to explain. See here, I am taking this column which is CD. So this one will be C and this one will be D. See here, for MCD it will be anti-clockwise movement which is acting 150. And MDC again anti-clockwise movement which is acting like this 150, 75. Okay, what I according to my logic, so there will be a column at C. Whenever a force will comes and act like this means it will move like this. So here also a force comes and act like this means this will move up to here, that is C dash. And again in the same sense, a force comes and act on this column like this means this will move up to D dash up to some distance here. So this distance is 75 unit force. So I am taking little bit 75, and this will be some 150. I am taking up to some long distance. Add these two, you will get the beam like this. So in the same way I am taking here and I will join those two. This one will be 150. And here it will be 75. And I am adding these two. Okay. So this is the fixed bending moment diagram based on the obtained final moments. After that, for resultant bending moment diagram, we can consider both fixed bending moment diagram and free bending moment diagram. What is the free bending moment here? Based on the loading conditions. Based on the loading condition. See here. So a uniform distributed load is acting on this column, acting on this frame. If uniform distributed load is acting, so if uniform distributed load is acting means, then you will get the bending moment diagram in the form of the parabola. Sorry, I will draw based on this UDL parabolic diagram. Okay. So already we know the values of the diagram. This one will be 70, this one will be 75, and both here 150 for C and D, here 150 for C and D, and here also 75. And what about this span? This value taken from here to here, and how much it will be? Already we know according to the formula, for whenever an UDL is acting, the free bending moment diagram area will be WL square by 8 whenever an UDL is acting. So if you simplify, how much you will get? 100 into 6 square by 8. So you simplify directly by using your calculator. How much you will? So after simplifying, you will get 100 into 36 by 8, around 450 kilonewton meter. So this one will be 450, and again if you want net moment means that 450 minus 150. So you will the total value will be 450, but you want net moment. Net moment means take down 450 minus 150, which is 300 kilonewton meter. You can simplify according to the manually only, no problem, you will get values directly and write down all the values. So this is the resulted bending moment diagram. So after obtaining the bending moment diagram, but in the frames, you can calculate the horizontal reactions also. Based on the horizontal reactions only, we can confirm whether the frame comes under the sway analysis or non-sway analysis. Why? Because some of the horizontal forcing acting on a particular frames will be equal to 0 for the non-sway conditions. You please check that one also. I will take this one. So I will solve here. Okay. So already we people know that. So this one will be A, B, C and D. So already the obtained final moments will be, that also I will take here. Okay. See here. Just I am assuming like this. The force will be acting, HA will be like this and this one will be acting like this. So if you take sum of the horizontal forces acting on a column will be equal to 0, means that is HA plus HD will be equal to 0. Therefore I am taking opposite in assumption, opposite in direction. So you have to calculate based on the obtained final moments. So what is HA? For calculation of the HA, horizontal reactions, that is HA. For calculation of these horizontal reactions, what is the formula? HA equal to sum of the column movements by the length of the column. Okay, HA will be equal to sum of the column movements, by length of the column. So sum of the column movements means, so what are the movements on a particular column AB? So there will be MAB will be equal to 75 and MBA will be equal to 150. So sum of the columns will be equal to plus 75 and plus 150. So I am taking 75 plus 150 divided by its length of the column. That length of the column will be equal to 3. So length of the column AB. So I am taking here AB. Only I am talking about the horizontal reactions and AB. So here you will get one more moment for BC. Don't take that one. Just to take the sum of the column moments AB. So after simplifying, how much you will get? 150 plus 75 around 225. So how much times you will get? 3 7 times P1 and again 55 times. So the horizontal reaction at A will be equal to 75 kilonewton meter. 75 kilonewton. Sorry, it will be in terms of meter units. So kilonewton only. And again HB. HB also taken equal to the sum of the column moments by length of the column. Length of the column CD. That one will be equal to sum of the column moments are, one will be CB, that one will be plus 150, another will be, sorry, CD and DC. So both will be anti-clockwise only, minus 150 and minus 75. So here we are taking 150 plus 75 divided by 3. That one will be equal to 75 kilonewton only. But here you will get a doubt, it will be in terms of negative. Therefore we are considering before itself anti-clockwise direction. Means if you consider both space HA and HB like this, means after obtaining the value you will get the value in terms of negative, then you can change in terms of positive. But while simplifying in the formula way, you just take down values in terms of positive only. But while doing manual calculations, then you will get the exact values, whether you will get the values in terms of positive or negative. I will calculate now based on the manual procedure also. Just remember the formula. Sum of the column moments means just take down the moments of 150 and 75 divided by the length of the column. But if there will be no horizontal loads acting on this particular column means, then it will be easy to calculate according to the formula. If there will be any such type of forces acting on this column like 2 kilonewton force which is acting at a distance of 1.5 and 1.5, some of the column moments on AB will be considered as only these two moments. Including those two moments, you can consider this force also in terms of moments, means force into distance, like so you can resolve this force to the end B or A. Then also this moment will be taken according to the negative or positive. Means all the time formula won't works. The manual procedure is only easy to remember, but if there will be no loads acting means directly take down in this formula. If there will be any forces is given like point load, eccentric load or UDL or any combination of the triangular loads, then at that time it is easy to calculate by using manual procedures also. But while calculating the formula, you have to remember the logic, whether this will comes under the negative or positive. I will show you that one also. Okay, see here, I am calculating the horizontal reactions, and again I will show you another procedure. Just resolving the force to one end. So already we solved so many problems based on that. So that is very easy. Just to take the column. Just to take the column. Just to take the column as it is. Just to this take the column. So we are calculating the reactions for column AB. I am taking that one also. Column AB. Here just assume any one direction, like horizontal direction towards right, or like that, like this also you can assume, no problem. You can assume either in right and towards left, and the entire movements already we taken like 75 clockwise movement and clockwise 150 movement. Then here resolving moments to one end, sigma mb will be equal to 0. What is the moment here? Taking entire moments about B, means I am resolving the entire moments up to the B. See here, what are the clockwise movements acting? Take down one side. Another anti-clockwise movements acting, take down another side. So see here, there will be two clockwise movements acting up to this ends. There will be 150 plus this one will be acting 75, and you can see here this horizontal force acting anti-clockwise towards B. So therefore I am taking the anti-clockwise side, that is HA. Up to what distance it will be acting? Entire column length. Force is into distance, HA into 3. So this is the moment, HA into 3. And simplify this one, you will get HA equal to 150 plus 75 by 3. Directly HA value will be equal to same 75 kilonewton meter. Like sum of the moments of the column toward the horizontal moment of by the length of the column. And while solving this type of procedure, so this is the procedure up to this problem is okay. And again, if there will be any force acting like this 1.5 meters distance, then at that time what we have to do means, you can add just extra like minus 120 into 1.5 minus. So this force is acting towards the B means minus 20 into 1.5. So don't take minus, because we are taking this anti-clockwise movement in the anti-clockwise side, means 20 into 1.5. And again simplify along with this value, you will get HA value like some x. Means whether you can take any uniform distributed load or eccentric load. So like this you can solve manually, means directly you will get the values like this. So for formula based problems, if there will be no point load or no UDL is given, then you can solve the horizontal reaction directly by using the formula, like sum of the moments on the column to the towards the length of the column. But whenever a load is given, so see the load and you can resolve directly to one end. Then it will be very easy to solve the formula, to solve the horizontal reactions on this particular problem. Similarly, I will take the horizontal reactions on CD. So I am here taking column CD. So there will be two loads, anti-clockwise moments are acting. So based on the anti-clockwise only, you can take the moments. So this one will be anti-clockwise 150 and this one will be anti-clockwise 75. So sigma mc equal to 0. So taking resolving entire moments about C, that is this hd into hb into, so here also I am considering force like this. If you want to consider like this also, you can consider, no problem. Okay, so here I am assuming direction like this. So resolve clockwise moments one side, anti-clockwise moments another side. Okay, so what are the clockwise moments? Here anti-clockwise moments will be this 150 and 75. Take down that one first. 150 and 75 one side. And the clockwise moment, this one will be acting, this HB into this 3 meters will be acting clockwise towards C, HB into 3. If you simplify directly, you will get 150 plus 75 by 3 will be equal to 75. Means around 225. 225 by 3, 3715. Okay, no problem. 75 kilonewton, I think. Then HA will be 75, which is in terms of positive, because your assumed direction will be correct. I will solve one more concept here. Here you can assume HB like this. So somebody will take directly HB like this. HB like this. So this one will be HD. So take down HD. Don't take HB here. Why? Because here we are taking end condition as D. So always take down this one as D, not HB. So here assuming HD towards right. Okay. See here, taking clockwise movements one side, anti-clockwise movements one side. So I am resolving this column movements. So what are the anti-clockwise movements here acting? This one will be acting anti-clockwise, this one will be anti-clockwise, and this HD also acting anti-clockwise towards C. That is, so total moments HD into 3 plus 1 will be 150, another will be 75. So there is no clockwise movements are acting, taking this one as 0. And after simplifying, you send these two values this side, means you will get negative value. So whatever the value obtained here is negative 75 kilonewton, means that is negative 75 kilonewton. So what happens whenever you will get negative value after solving the formula, then what we have to do means, already we learned in our basic classes itself, that is you just change the assumed direction whatever it may be and take down like this. If you will get negative means just change the sign and reverse the direction, means the assumed direction here is negative, means it is wrong, therefore you can change the direction and change the sign, like in HD equal to like this. So here assumed direction, this one will be correct, this one will be wrong. So after obtaining negative symbol, after that you will know that whether the assumed direction is correct or not. So finally HA will be acting like this and HD will be acting like this. So some of the moments will be taken as HA, some of the horizontal moments will be taken as HA plus HD. One will be acting towards like this, another one will be towards like this. Means HA minus HD, that is plus 75 minus 75 will be equal to 0. So this 0 represents the non-sway analysis. For example, if you will get any values like some minus 1, 2, 3, 4 any or plus 1, 2, 3, 4 any value, that problem will comes under the sway analysis, because that much of horizontal forces will be exist on that particular column. If there will be 0 means there will be 0 horizontal forces acting on that column, therefore this problem will be solved under the non-sway analysis. This is the way for finding the horizontal reactions. And next topic is very simple topic, which is vertical reactions. So then finding the vertical reactions. So finding the vertical reactions are very simple. See here, this one will be VA at reaction D, this one will be support D, VD. At support A you will get VA. So already the people know that one condition on a simply supported beam, any load, for example uniform distributed load is acting, the load will be distributed equally. For example W will be acting means along with the length, W equal to W into L, means 600 load will be acting here. It will be distributed equally like 300 kilonewtons and 300 kilonewtons. Like that you will get directly here. Similarly, if any point load is acting means, for example point load of 150 kilonewton is acting means W by 2 W by 2, which is 75 and 75 will be acting. And at the same time on a simply supported beam an eccentric load is acting. At that time what happens? This is at the distance of A means W B by L and here W A by L. Like that the calculations you will get directly. But symmetrical portal frames, if you go for manual calculations also, no problem, not a big deal. Why? Because here moment BC and moment CB, one will be acting anti-clockwise, sorry, moment BC will be acting anti-clockwise and moment C will be acting clockwise. Here both moments will be cancelled while calculation. So no need to consider that moments, because of the symmetrical condition one will be acting 150, another will be acting minus 150. For example here it will be 75 and here it will be 150 means, then you can calculate manually that one also. So while solving these so many problems you will know in what way you have to calculate the vertical reactions. But whenever symmetrical conditions happen means, then you can take down the vertical reactions directly, like you can distribute the load based on the simply support, analyzing the simply supported beam condition only. So you can solve this one manually also. All these things you can learn in your basic level itself in the strength of materials and engineering mechanics itself. So this one will be VA and this one will be VD. So I am resolving entire moments about D equal to 0, means up to here this position. So see here there will, how many vertical reactions are there? So here the same reactions acting here also. Why? Because entire line the force is same, means VA into VD, means this force is acting VA into this distance D. So this distance is 6 meters. So clockwise movements taking one side, anti-clockwise movements taking one side. So forces VA into 6, VA into 6. And is there any horizontal forces acting on that particular column while taking vertical column reactions means? So there will be no any vertical forces is acting. So and here there will be downward forces acting, that is 100. So take down 100 into 6. 100 into 6, that is the entire force, and it will be taken from the center, always taken from the center at a distance of L by 2. W into X into X by 2. In the same way W into L into L by 2. So W into L into L by 2. So this one will be acting downwards like this and this one will be acting towards upwards, means one will be clockwise, another will be anti-clockwise. So simplify this one 3 times and again this 6 and this 6. So we will get 300 kilonewton directly. So sum of the vertical reactions will be equal to 0. VA and VD both are acting upwards and VD will be acting downwards, that is 100 into 6. So VA will be around, already we know VA will be equal to 300. So VD equal to 600 minus 300, you will get 300 kilonewton. Both VA and VD will be equal to 300 kilonewton. So this is the way for finding the vertical reactions. Okay, so if there will be any horizontal forces also, no need to consider. Why? Because that is the horizontal force. Here we are considering only vertical forces. Vertical forces means whatever the forces which is acting on the member BC only, or any horizontal members is there, then only you can consider vertical forces. So this is the way for finding the horizontal reactions, vertical reactions, and the procedure. So here I explained method 1, method 2, in what way you can calculate the slope deflection method based on the shortcut and in the manual procedure, and I explained the sway conditions and non-sway conditions, and I also clearly explained manually and the formula based horizontal reactions, and I also explained directly the vertical reactions whenever simply supported, consider simply supported beam and the load will be distributed equally like that, and again I explained manually also. Friends, I hope you understand this lecture. In the next lecture I will explain the same non-sway problem. Both ends will be simply supported, like here it will be hinged and here it will be hinged, and here also it will be hinged. Then both final moments like AB and DC will be equal to 0. At that time also your problem calculation will be very simple, but at this time I won't explain all these horizontal and manual reactions once again. Just I will explain a problem which is based on the shortcut way and a simple way, which I will close the entire problem in 30 to 45 minutes only. So I hope you understand this lecture. Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.